In section 8.5, we're multiplying and dividing rational expressions. Our objectives are to multiply radical expressions, rationalize denominators with one radical term, rationalize denominators with binomials involving radicals, and write radical quotients in lowest terms. Let's begin by multiplying the square root of 7 times the square root of 5. We can multiply these together to get the square root of 7 times 5 as a single radical, which is simplified to the square root of 35. Now, there are no perfect squares that are factors of 35, so this one can't be simplified any further. On the right side, we have 3 radical 5 times 2 radical 7. Let's write this, simplify this by multiplying the coefficients, 3 times 2, and the square root of 5 times the square root of 7 as the square root of 5 times 7. This can be simplified as 3 times 2, which is 6, and the square root of 5 times 7 is the square root of 35. Again, this is a radical that can't be simplified any further. Let's do the example on the bottom by using the distributive property. We're going to be multiplying the square root of 3 times each term that's in the parentheses. When we multiply, to begin, we have the square root of 3 times 2 square root of 6, which we could write as 2 times the square root of 3 times 6, minus square root of 3 times 5 times the square root of 12, so we can write this as minus 5 times the square root of 3 times 12. When we simplify this, we can factor the 6 here as 3 times 2. So this becomes 2 times the square root of 3 times 3 times 2. And with those 3 times 3's being a perfect square, that can simplify to 2 times 3 out in front of the radical, and this 2 factor that's not part of a perfect square stays under the radical. So our first term is simplified to 6 square root of 2. Now let's look at the second term and simplify that as well. We see that 3 times 12 can be written as 3 times 12, which is 36, and 36 is a perfect square. So we can write this second term as minus 5 times the square root of 36, which is 6, and 5 times 6 is 30. So this is our answer simplified when multiplying the radical square root of 3 times the binomial 2 square root of 6 minus 5 square root of 12. All right, in this example, we see the entire quantity, 3 square root of x minus 2 square root of y, the entire quantity is squared. To solve this type of equation, we want to write this as 3 square root of x minus 2 square root of y times 3 square root of x minus 2 square root of y, and make sure to use the FOIL process. The first, the outer, the inner, and the last. So when we multiply the first, the 3 square root of x times the 3 square root of x, we're going to get 3 square root of x times 3 square root of x, which is going to simplify to 9 times the square root of x squared. Well, 9 times the square root of x squared can then further be simplified as 9x. Our outer term can be written as 3 square root of x times this minus 2 square root of y. So minus 3 square root of x times 2 square root of y. And that can be simplified by multiplying the coefficients 3 times 2 to get our minus 6 square root of xy. The inner is negative 2 square root of y times 3 square root of x. So we can write that as minus 2 square root of y times 3 square root of x. And that can then be simplified by multiplying the coefficients 2 times 3 to get 6 square root of xy. And now notice that these two middle terms are like terms. The outer and the inner can be simplified to minus 12 square root of xy. And then finally our last, the L step here, is negative 2 square root of y times a negative 2 square root of y, and the negative 2 times a negative 2 can be written as the positive 4 square root of y squared. That's plus 4 square root of y squared, which then that can be simplified to plus 4y. So our original entire quantity squared we can write out as two separate binomials, and use the FOIL process to simplify. Let's do the same process with the problem on the right side. Let's multiply. First, rewrite this as the square root of x plus 3 times the square root of x plus 3. Now we can use the first outer inner last process to multiply. The square root of x times the square root of x is the square root of x squared, and that will simplify. The square root of x times the plus 3 on the outer is plus 3 square root of x. The inner plus 3 times the square root of x is another plus 3 square root of x, and the last plus 3 times this positive 3 is a positive 9. Now we can simplify and combine like terms. The first term, square root of x squared, can be simplified to x. The middle two terms are like terms, so we can combine those. 3 square root of x plus another 3 square root of x is 6 square root of x. And then finally, that last term is a plus 9. So we end up with x plus 6 square root of x plus 9. Rationalize denominators with one radical term. A simplified radical expression has no radical in the denominator. The process of removing a radical from the denominator of a fractional expression is called rationalizing the denominator. Let's rationalize the denominators with one radical term. We have 5 divided by the square root of 6. This can be simplified by multiplying the denominator by something so that we end up with a perfect square under the radical. We can multiply the denominator by the square root of 6. Now, whenever you're working with a fraction and you multiply the denominator by something, you need to also multiply the numerator by the same quantity. So we're going to multiply the numerator by square root of 6 as well. When we multiply the numerators together, we have 5 times the square root of 6, or 5 square root of 6, all divided by the square root of 6 times the square root of 6, which is the square root of 36. And then we can simplify that even further with a 5 square root of 6 in the numerator, and the square root of 36 is 6. So that would be our final answer. Let's look at the example on the right side here. We have the 2 square root of 3 over 5 square root of 2. And we can multiply the denominator by the square root of 2 as long as we multiply the numerator by the square root of 2 as well. So in the numerator, we get 2 square root of 3 times the square root of 2, which is 2 times the square root of 3 times 2. And in the denominator, we have 5 times the square root of 2 times the square root of 2, which is 5 times the square root of 4. Now the square root of 4 can be simplified. The numerator can be simplified to 2 square root of 6, and the denominator can be simplified to 5 times the square root of 4, which is 2. Now we do have a common factor in the numerator and the denominator, that the 2 in the numerator can divide out with the 2 in the denominator. Notice neither one of those is under a radical, so it's okay to do this as long as your factors, common factors, are next to any multiplication. Then we can write our final answer as the square root of 6 in the numerator over 5. And for our example at the bottom of the page here, we have the square root of 7 over 12. Let's write this as the square root of 7 in the numerator over the square root of 12. Now it is possible to do this several ways. One thing you could do is multiply both the numerator and the denominator by the square root of 12. However, we'll end up having to do some extra steps in simplifying. Another approach would be to multiply the square root of 12 by something to make it a perfect square. In fact, the perfect square that 12 is a factor is 36. So if you multiply the denominator by the square root of 3, we're going to end up with a nice perfect square under the radical. And whenever you multiply the denominator by something, you also need to multiply the numerator by the same value. When we multiply the numerators together, we get the square root of 7 times the square root of 3, which is the square root of 21. And in the denominator, we have the square root of 12 times the square root of 3, which is the square root of 36. Now that's a perfect square, so we can simplify this. The square root of 21 in the numerator over 6 in the denominator. And that is how we can write our final answer in factored form. Now notice all of the original problems started off with a radical in the denominators. And whenever this is the case, we don't consider that expression to be simplified. So we want to get rid of any radicals in the denominator. Notice that our resulting denominators don't have any radicals in it. That's the whole point of rationalizing the denominator. So your denominators don't have any radical signs. Let's go back to the original example on the bottom of the page and show you another way that you could solve this example. So we started off with the square root of 7 over 12, and then we can write this as a square root of 7 in the numerator over the square root of 12. Now often when rationalizing the denominator, we go for multiplying it by itself, the denominator by itself. So if you multiply the denominator by the square root of 12, you also want to multiply the numerator by the square root of 12. So we get in the numerator, we get the square root of 7 times 12 in the numerator, and in the denominator you get the square root of 144. And that's a perfect square. So we can then write this as the numerator, which we'll end up having to simplify later. So let's write this as in factored form. If we factor 12, we get 4 times 3. And in the denominator, the square root of 144 is 12. Now notice that the 4 factor is a perfect square. So we can write this as a 2 out in front of, because the square root of 4 is 2, that comes out in front of the radical, and 7 times 3 is 21. We can keep underneath the radical, all over the denominator of 12. Now, this is a rational expression, but it's not simplified because we have a common factor of 2 in the numerator and the denominator. So if we factor out a 2 from the numerator, we could say 2 goes into 2 one time, and 2 goes into 12 6 times. So this final answer can be written as the square root of 21 over 6. Now we got the same result in this example here, where we multiplied the numerator and the denominator by the square root of 3. And what that did is gave us the smallest perfect square in the denominator. And then we didn't have to do that extra simplifying step. Okay, we have the square root of 98c to the third over d to the 7th power. We want to rationalize the denominator by making the denominator so we have a perfect square. Now the denominator is a d to the 7th, but our index for this radical is 2, so we want to take out perfect squares. What we can do here is write this as the square root of 98c squared in the numerator, and 98 can be written as 2 times 49, and c cubed can be written as c squared times c to the first. And since this is a square root, we're taking out perfect squares. This 49 is a perfect square, so that can come out in front of the radical, and c squared is a perfect square. In the denominator, we can write the square root of d to the 7th, which can be written as d to the 6th power times a d to the 1st power. Let's continue to simplify here. And we get the numerator can be simplified to the square root of 49 can come out as a 7 in front, and the square root of c squared can come out as a c out in front, and the square root of 2c, the 2 is not part of a perfect square, and this c, the 1st power, is also not part of a perfect square. In the denominator, this d to the 6th can be written as a d to the 3rd. We can think of it as d to the 3rd to the 2nd power, so that's a perfect square, and then we have this d. Let's look at our numerator is 7c square root of 2c, And our denominator, when you simplify it, that d cubed squared is a perfect square. The square root of d cubed squared is d cubed times the square root of d. Now this is simplified, but it's not simplified completely because we have a radical in the denominator. To take care of that radical in the denominator, we're going to multiply the denominator by the square root of d. That would make it another perfect square. And whenever you multiply the denominator by something, you want to also multiply the numerator by the same value. When we simplify the numerator, we have 7c times the square root of 2c times the square root of d. We can write this as the square root of 2cd, all as one radical. In the denominator, we have d cubed times the square root of d squared. Now the index of 2 and the power of 2 are inverses, so that can be simplified. So we can write this as 7c times the square root of 2cd all over d to the third times d to the first, the square root of d squared being d. And then finally we can write our answer numerator as a 7c square root of 2cd, and the denominator is a d to the fourth. So this problem involved simplifying the radicals as well as rationalizing the denominator, multiplying the denominator by this square root of d and the numerator by square root of d so that we can get rid of the radical that's in the denominator. All right, let's look at the example on the right side. We have 7 over the cubed root of 4. Now we want to multiply the denominator by something that will make it a perfect cube. So we can write this as 7 over the cubed root of 4, which is the same thing as 2 times 2. We would like to multiply the numerator and the denominator by something so that the denominator is a perfect cube and can be simplified and written without a radical. So we can multiply the denominator by the cubed root of 2 to make it a perfect cube. 2 times 2 times 2 is 8, which is a perfect cube. And if we multiply the denominator by the cubed root of 2, we need to also multiply the numerator by the cubed root of 2. So this equals, in the numerator, we have 7 times the cubed root of 2 over the cubed root of 2 times 2 times 2, the cubed root of 2 times 2 times 2, which is the cubed root of 8. So we can write, again, the numerator is 7 times the cubed root of 2 over the cubed root of 8, and 8's a perfect cube. So we can write our final answer as 7 times the cubed root of 2, all divided by 2. That is our final answer, simplified by rationalizing the denominator. To rationalize denominators with binomials involving radicals, we want to recall that the product of x plus y and x minus y is by using the first, outer, inner, last. The first, x squared, the outer is minus xy, the inner is plus xy, and the last is minus y squared. The outer and the inner will drop out, and we end up with this difference of squares. We're going to use that fact when we're simplifying radicals or rationalizing the denominator when the denominator has a binomial expression. So here's our example. We have 4 in the numerator over 5 minus the square root of 2. We must use conjugates to rationalize the denominator. The conjugate of 5 minus square root of 2 is 5 plus square root of 2. So in general, x plus y and x minus y are conjugates. So if we were to multiply the denominator by the conjugate, 5 plus the square root of 2, we would also need to multiply the numerator by the conjugate, 5 plus the square root of 2. When you multiply the numerator by 5 plus the square root of 2, you're going to distribute 5 times 4 being 20 plus 4 times the square root of 2, 4 square root of 2. In the denominator, you need to use the first, outer, inner, last because you're multiplying a binomial times a binomial. The first is 5 times 5, which is 25. The outer is plus 5 square root of 2, The inner is minus 5 square root of 2, and the last is negative square root of 2 times square root of 2, which is negative square root of 4. We're going to do another example very similar to this on another slide. So bear with me as I work through the problem here. We have 20 plus 4 square root of 2 in the numerator, and the denominator. Notice something very nice about multiplying by the conjugate. The outer and the inner term are opposite, so that's going to end up resulting in with a answer of 0. So we have our 25 first term, and the outer and the inner cancel out, minus the square root of 4, which is minus 2. And then we can write our final answer in simplified form as 20 plus 4 square root of 2 all over 25 minus 2, which is 23. Thus, we can write our final answer as a simplified radical so that there's no radical in the denominator. Rationalizing a binomial denominator is a recap. Whenever a radical expression has a sum or difference with a square root radical in the denominator, rationalize the denominator by multiplying both the numerator and the denominator by the conjugate of the denominator. All right, let's simplify this radical expression by rationalizing the denominator with binomials involving radicals. The way we simplify this is to multiply by the conjugate of the denominator. Since 5 minus square root of 2 is in the denominator, the conjugate is 5 plus square root of 2. And whatever you multiply the denominator by, you want to also multiply the numerator by the same expression. Now we can simplify the numerator. 1 times 5 plus square root of 2 is 5 plus the square root of 2. And in the denominator, using the FOIL process, the first is 5 times 5, which is 25. The outer, 5 times the plus square root of 2. The outer is plus 5 square root of 2. The inner is the minus square root of 2 times the positive 5, which is negative 5 square root of 2. And then the last, the negative square root of 2 times the positive square root of 2 is negative square root of 4, which is negative 2. The outer and the inner terms, when you multiply by the conjugate, are always going to be opposites, so they're going to cancel out. And the numerator, we get 5 plus square root of 2. And in the denominator, the outer and the inner, the middle two terms, cancel out to get 25 minus 2, which is 23. And this is how we can write our answer in simplified form, and it's simplified because we have no radicals in the denominator. The example on the right side, we have 7 divided by the square root of 6 plus the square root of 2. We're going to multiply the denominator by its conjugate, which is the square root of 6 minus the square root of 2. We multiply the denominator by that quantity. We need to also multiply the numerator by the quantity, square root of 6 minus the square root of 2. Let's simplify the numerator. We can distribute the 7 in the numerator to get 7 square root of 6 minus 7 square root of 2. And in the denominator, we can do the FOIL, the first, outer, inner, last. The square root of 6 times the square root of 6 is the square root of 36, which is 6. The outer is your square root of 6 times the minus square root of 2, which will be minus the square root of 6 times 2, or minus the square root of 12. The inner, which is the square root of 2 and the square root of 6, multiply those together to get plus the square root of 12. And then the last, when we have the square root of 2 times the negative square root of 2, that is minus the square root of 4, which is minus 2. The outer and the inner will cancel out, their opposites. And then our numerator is written as 7 square root of 6 minus 7 square root of 2. All over the denominator, where the outer and the inner are opposites, you get 0, and the result is 6 minus 2, which is 4. This is our answer in simplified form. Let's look at the example on the left. We want to simplify the rational expression by multiplying the denominator by the conjugate. And the conjugate of 2 square root of 3 plus square root of 2 is 2 square root of 3 minus the square root of 2. And when we multiply the denominator by that amount, we are going to multiply the numerator by the same expression, 2 square root of 3 minus the square root of 2. In the numerator, we're going to use the FOIL process as well as the FOIL process in the denominator. So we're going to do our first, our outer, our inner, and our last. When we multiply the first in the numerator, the 2 square root of 3 times the 2 square root of 3, this is your 2 square root of, oops, go back there, sorry about that. 2 square root of 3 times 2 square root of 3 is 2 times 2, which is 4 times the square root of 9. That's going to simplify. The outer is 2 square root of 3 times negative 2, and that's going to be minus 2 square root of 6. The inner is negative square root of 2 times 2 square root of 3, which is another minus 2 square root of 6. And the last is negative square root of 2 minus the square root of 2, which is plus the square root of 4, which we will be able to simplify the numerator. We'll do that in the next step. Let's use the FOIL process in the denominator. 2 square root of 3 times 2 square root of 3 would be 4 square root of 9. The outer, 2 square root of 3 times negative square root of 2 would be negative 2 square root of 6. The inner, the positive square root of 2 times 2 square root of 3 would be plus 2 square root of 6. And the last would be plus square root of 2 minus the square root of 2, or minus the square root of 4, which we'll be able to simplify. So our 4 square root of 9 in the numerator is the same thing as 4 times 3, which is 12. The minus 2 square root of 6 and another minus 2 square root of 6, we can combine those to get minus 4 square root of 6. And the last term in the numerator, the plus square root of 4, can be written as plus 2. And that will simplify in the next step. Let's simplify the denominator. 4 square root of 9 is 4 times the square root of 9, or 4 times 3, which is 12. In the denominator, the outer and the inner, the middle two terms, will be opposites, and that is always going to happen when you multiply by the conjugate. So those two terms will cancel out, and then minus the square root of 4, which would be minus 2. And now we can simplify. We have in the numerator 12 plus 2, which is 14, plus 4 times the square root of 6. And in the denominator, 12 minus 2 is 10. Now this is another way to write our answers, but it's not completely simplified. There is a factor of 2 that you can take out of both terms in the numerator. If you factor out the 2, you'll be left with 7 plus 2 square root of 6. And you factor a 2 out of the denominator, 2 times 5, cancel out those 2's, and then our final simplified form is going to be 7 plus 2 square root of 6 in the numerator over 5 in the denominator. Again, we simplify radical expressions by rationalizing the denominator, multiplying the denominator by the conjugate. On the right side, we have 2 plus the square root of 8 minus, all divided by 2 minus the square root of 8. We are going to multiply by the conjugate of 2 minus the square root of 8, which is 2 plus the square root of 8. We're going to multiply both the numerator and the denominator by that 2 plus square root of 8. Again, using the FOIL process in both the numerator and the denominator, we get our numerator, 2 times 2 for the first is 4, plus 2 times the square root of 8, 2 square root of 8, and then square root of 8 times 2 is another 2 square root of 8, and our last in the numerator is plus square root of 64, which we'll be able to simplify. In the denominator, our first, we have 2 times 2, that's going to be 4. The outer is 2 times square root of 8 is plus 2 square root of 8. The inner is negative square root of 8 times 2, which is minus 2 square root of 8. And the last is minus square root of 8 times square root of 8, or minus the square root of 64. Let's simplify these by combining like terms. In the numerator, we have 4. The the plus 2 square root of 8 plus another 2 square root of 8, those are like terms. We can write that as plus 4 square root of 8. And the square root of 64 is 8. So we can write it like that. And in the denominator, the outer and the inner, the middle two terms are opposites. So those will cancel out. And we're going to have 4 minus the square root of 64, which is minus 8. Let's simplify the numerator. 4 plus 8 is 12. 12 plus 4 square root of 8, all over the denominator of negative 4. Now we can write this as two separate terms, dividing each of those by negative 4. So we can write this as 12 divided by negative 4 plus 4 square root of 8 divided by negative 4. There is a common factor of 4 in the numerators and the denominators, so this can be simplified to negative 3 minus the square root of 8. Now, another thing we can do to simplify this is to simplify the square root of 8. The square root of 8 can be written as, let me kind of go over here in the middle, negative 3 minus 2 square root of 2. So that would be our final answer in simplified form. Again, simplifying the radical square root of 8 as 2 square root of 2.